link servers one at a time. The other example, when we can enumerate the linked servers in LVA, and we find out, yes, there's a link to DB1, we can do the same union statement, select data, but this time instead of selecting data from the local sysservers table, we actually execute OpenQuery and tell OpenQuery to get data from DB1. So at this point, we actually running the command. Running the command on the database DB1. So now we select top 1 server name from select top 1 server name from master sys servers. And the same thing, we can increment the inner top 1 and get 1 server at a time from the DB1 sys servers table. So we can enumerate all the tables that, or all the links that are on DB1. At that point, there's a link from DB1 to HVA. So we can repeat the same thing. We can do the same union select. This time we're not even selecting anything. We just say select null, 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 null. Run OpenQuery on DB1. So we're executing the next query on DB1 database. But on DB1 database, we say, let's run this query actually on HVA database. So what we can do here, we can just execute SQL queries on different databases. And at this point, from HVA, we select null. So we're not really even returning any data from HVA database. That's because the OpenQuery syntax requires that you select some data and return some data. If you Google it, people will say, no, you can't execute commands through OpenQuery. But you can just the same way as earlier, we just end the first SQL statement. Then we call the sp send mail command. Send email to consultant@netspi.com and run a xp command shell, get a directory listing, email that to us. So at that point, we're executing commands through the OpenQuery. The other thing to notice about the query is when you do these nested SQL injections or SQL queries, you have to always double up on ticks. So when you do ticks inside ticks, first you have 1 tick, then you have 2 ticks, then you have 4 ticks, then you have 8 ticks. So the injections get a little bit confusing, but it's not very complex. It just makes it easy to typo those. And in the last example, we execute the same OSQL that Scott talked about on the HVA database. This time we just execute it all in one single injection. So we're not even writing any files on HVA server. So what we do, we once again go through DB1 to HVA and say, email us the following query. And this time we run xp command shell. We do OSQL-L, so we list all the databases in the network. We put those results to a for loop. And from the for loop, we run OSQL again, -s/i, -e. So like Scott said, now we're using the service account on HVA database server, and we select all the server names, all the databases on those servers. So at that point, in one single injection, we use the backend database that's not LVA, not DB1, it's HVA, to scan for databases, database servers and databases.
Yeah, sorry. One thing I'd like to add to that, in that example, you kind of saw a combined attack. He used the database links first and then went to database shared service accounts basically was the target. But those things can work either way. You can have a breached database server. You can use the links to get to the shared service accounts, but you can also get on a shared service account that then eventually links to another set of databases you previously didn't have access to. So it doesn't necessarily need to be a static linear path or anything like that. So thank you, Antti. With that said, let's talk about the fixes quickly. We're running a little bit low. First of all, provide the basic education we talked about. Try the materials, try the training. Make sure you have just at least a general understanding of, or your coders and your administrators have a general understanding of what the best practices are. help them understand the relationships between these layers, because if they don't, you're going to run into these types of problems, and it's not the exception, it's kind of the rule, unfortunately, from what I've seen. Also assign ownership in these gray areas. What I've seen very often is, if a dev team wants to create a database, they basically have to call out the database, the database name, all the tables, the entire schema, and then call it what privileges each user needs. And then they don't assign anything more than that. Just having a simple form can go a long way in kind of resolving some of those issues. And the same kind of applies to your SQL group or your database administrative group. They're probably most likely to know more about what the privileges of their database server needs than the server team who's just managing the server as a whole. Next, use the unique service accounts whenever possible for databases. I have seen some companies kind of take a hybrid approach where you have low-value applications using a shared service account and high-value applications over here using a shared service account. But the problem with that is you have these two groups of shared service accounts. If there's a single link between them that has excessive privileges, you're kind of SOL again. So best practice is unique service account for each database in your environment. And then, of course, the theme, as you may have noticed, is kind of configure all your accounts and services with least privilege. This should really apply to anything in your environment, whether it's a system, account, server, whatever. And then last but certainly not least, we didn't put this at the top for the reason. I mean, obviously, we came in through the SQL injection for all of these scenarios and kind of blew it up. But I put it at the bottom because I really wanted to make the point that when you have these types of relationships configured, you're not just giving access to your external attackers, you're giving access to all your internal resources. The database administrators, the server administrators, your developers, everybody can potentially be a domain admin if they want to. So I wanted to keep that in mind, but yeah, sanitize your user input, because from the internet perspective, it's really going to be one of your best defenses, even though there's lots of other things that you can do. So, quick wrap up here before we move to the demo. Low value apps, bad. Basically, they can be used as a launching pad into high value applications, and then use those 5 basic steps. They're pretty kind of common sense tools for helping create a little bit more secure environment to prevent some of these things from happening in your applications and your implementations. So that I'll hand it back over to Antti, and he'll show you a quick demo of how this actually works. Assuming the VMs don't crash.
Okay, so for the demo, Scott created this great application that allows you to list employee information. So we click employee, we see all the employee information. In the URL, there's ID parameter. Surprisingly, there's a SQL injection there, so if we put a tick there, we can see that it actually breaks the SQL query. So what we'll do here, I'll just run through the same scenarios, a little bit different SQL syntax that we used earlier, but what we do, we enumerate all the databases, create, scan the network for database servers, and get all that information back to us. All of it done with normal Windows commands, MS SQL syntax. The only real exploit here is just the SQL injection. So first query, what it does, it just lists all the server names in the sysservers table. We added little language there so that it shows clearly that from server LVA, there's a link to server DB1. Also from server LVA, there's a link to LVA, so there's always a link to itself. And you can configure a link to yourself with excessive privileges. So you could have least privilege, but through the link to yourself, you could escalate your privileges if someone wants to do that. The other one, very similar, what we do now, we do the same thing, but in addition to what we did earlier, we run this all through OpenQuery and run the actual select statement on the DB1 server. So now we get the results back saying from server LVA, there's a linked server DB1, and from DB1, there's a linked server DB1 there's a linked server HVA, and from DB1 there's a link to itself. And last one, we just nest more open queries inside. So there's one more open query, so now it actually executes the command on HVA database, and we can see that that's as far as our database link chain goes. What we want to do now, we want to know if we automatically have excessive privileges on any of these databases. So the easiest way, of course, we want to get the XP command shell, then we won't have to try any other tricks to escalate privileges. So we run a query that checks if we are sysadmin on the system where we're running the query. Then it does a little case statement there. It tells us yes we are or no we're not. So what this one does, I'm running the query on LVA, and in the user field you can see it sends back a result saying I'm not the sysadmin on server LVA. We can follow the database link chain, go to all the linked databases. In the next example, we run the same query that just checks if we are sysadmin. Now it does it through OpenQuery and DB1, and from there with OpenQuery to HVA. And we can see that at this point we are sysadmin on server HVA. So at that point we know that we can execute XP command shell, do whatever we want. But what we want to do here is we want to scan the network for databases, look for database servers, database names. The first injection, what it does, it just echoes column 1, column 2 to a text file so that we know the column names on the file that we'll create next. As you can see at this point, like I mentioned earlier, the open query has to return something, but we chose to return null. So we're not actually seeing any output from the injection. But because there's no error, the injection works. Next one that we do, like we talked earlier, we run a union statement that runs open query on DB1, and from DB1 it runs an open query on HVA. And because we are sysadmin there, we can run the XP command shell, we can run OSQL-L, put the results from that to a for loop that runs another OSQL command. And the OSQL command lists all the database server names and databases on those servers. So this one will take a little while, 30 seconds or so. So what it's doing now, it's executing the OSQL command on the HVA server, writing the results to a file. And soon it should time out. And after we get the file on the server, we will use the same functionality that we just exploited to get or used to get to the HVA database. We'll create a link from HVA to the text file that we just created on that system. Using command or stored procedure at linked server, we create a link called temp and tell it to link us to the root of C drive to any text files that are there. Like I mentioned, now it timed out, so the file is ready. We create the link, no error, so the link is done. What we also need to do, we'll run another stored procedure, HVA, add linked server login. So we set the permissions on that link so that we can actually read it. And that's completed as well. And the last injection that we'll do, it runs OpenQuery to DB1 and OpenQuery to HVA. And from HVA, it actually runs another OpenQuery. And this time it runs the select statement on the temp link that we just created. And it selects column 1 from dbs.txt. And because we echoed all the, or stored all the database information, to the DB